Okay, good morning. Today we're going to derive the five equations for kinematics, which will help us to solve various kinematic problems or worded problems for that matter. Okay, so the first two equations is quite simple, which is average velocity. The first one is average velocity. From average velocity, which is uh, average velocity, which is the change in distance divided by change in time, or simply put, that is displacement divided by time. Okay? But what is average velocity? Average velocity is the final velocity plus the initial velocity divided by 2. Since that is average, we have two values, we add it up, then we get the uh, half of the sum. That's average, or we divide it by the number of elements that we summed up. So this is equal to distance all over time. So deriving distance, we have transfer time on the other side. So we multiply everything by time. Distance will now be equal to 1/2. So I extracted 2. I drew it outside. We have final velocity plus initial velocity multiplied by time. We multiply everything by time. So this is our first equation. The second equation, so we have here equation 1. The second equation is from the derived from, or rather, it was derived from the equation for acceleration. So acceleration is equal to the change in velocity per unit of time. So what is the change in velocity? So change in velocity, acceleration is the change in velocity should be the final velocity minus the initial velocity divided by time. So rearranging or multiplying everything by time, we have acceleration divided multiplied by time equal to final velocity minus initial velocity. Changing the position of both of all the elements, we have final velocity minus initial velocity equal to acceleration multiplied by time. And transferring initial velocity on the other side, since this is negative, it will become positive. So we have final velocity, which is equal to initial velocity plus acceleration multiplied by time. So we have equation number 2. The other three equations was derived from these two equations. Okay. So the first one, we will use this part and no, not exchange, and derive from here the value of time. Okay, so we have v final minus v initial equal to acceleration multiplied by time. So let's try to solve for time. Time would be equal to final velocity minus initial velocity divided by acceleration. So let's use this in equation 1. So if we're going to use this in equation 1 it says that distance or displacement is equal to 1/2 final velocity plus initial velocity multiplied by time. So let's use this change time. Use this one on time. So we have displacement is equal to 1/2 times final velocity plus initial velocity multiplied by we have final velocity minus initial velocity divided by acceleration. So this now is our time. Then factoring out acceleration, putting it beside 2, so we have displacement is equal to 1 over 2a, 2 is the acceleration, and we have multiplied by final velocity, the sum of the initial and the final velocity, and the difference between the initial and the final velocity. Okay? So we could transfer 2a, or twice the acceleration, on the other side by multiplying everything by 2a, which will give us 2ad. Okay, so have we now have uh, only the velocities on one side, and this here is the product of the sum and difference of two numbers. So if you remember in algebra, the sum and product of two numbers, x plus y times x minus y, is always equal to x squared, rather, minus y squared. So that means that we just need to get one velocity, square it, and then subtract it with the square of the other velocity. So Vf, so if this is x, this is y. So Vf squared minus Vi squared. Or transposing Vi on the other side, this will become Vi squared plus 2AD should be equal to Vf squared, and solving for, or exchanging the position of the two. So we have Vf squared should be equal to Vi squared plus 2AD. So we have equation number 3. And for the last two equations, we will utilize equation number 2 and use it all once again in equation number 1. Okay, so let's have equation number 2. Equation number 2 states that Vf is equal to Vi plus acceleration times time. Equation number 1, displacement is equal to 1 half Vf plus Vi multiplied by time. So we will use Vf to find Va plus At. So let's change this Vf to Vi plus At. So that means displacement should be equal to 1 half Vf should be equal to Vi plus acceleration times time. So this is now Vf plus Vi multiplied by time. So as I told you before, this is Vf. This was the Vf here. Ito. Ito yung ating kaninang Vf. Okay? So solving for displacement, once again, we will have displacement should be equal to 1 half Vi plus Vi, that is 2 Vi plus acceleration times time multiplied by time. Now, distributing 1 half to the two equations, we have displacement should be equal to 1 half times 2, that's 1. So, oh, right, yeah, it's Vi. Okay, so that is Vi, then 1 half times 80, so that is plus 1 half acceleration times time. Then we have also time on the outside. Then distributing time, displacement should now be equal to Vi multiplied by time plus 1 half acceleration times time squared. Now what about the last one? Okay, so this is equation number 4. Equation number 5 should also be from Vf is equal to Vi plus 80. But what is different would be, let's start first with that one. Vf is equal to Vi plus acceleration times time. So we transpose acceleration times time on the other side. So this is positive, it will become negative. So that is Vf minus acceleration times time should be equal to Vi. So we have your another equation. So using Vi in equation number 1, okay, let's use in equation 1 or used in equation 1. So we have here the equation 1 is distance is equal or displacement is equal to 1 half Vf plus Vi times time. Vi should be changed to Vf minus 80. So that's distance displacement is equal to 1 half Vf. This will become plus Vf minus acceleration times time multiplied by time. So once again, adding up the two Vf's, we have displacement is equal to 1 half 2 Vf minus acceleration times time multiplied by time. Distributing the 1 half, we have displacement is equal to Vf 1 half times acceleration times time minus 1 half acceleration times time. So the whole equation divide multiplied by time, and distributing time, we have displacement equal to Vf times time minus 1 half acceleration times time squared. So we have equation number 5. Now, how do we use this? Let's try to draw first. We have here the 5 equations. Equation 1, displacement is equal to 1 half Vf plus Vi times time. Equation number 2, Vf is equal to Vi plus acceleration times time. Equation number 3, Vf squared is equal to Vi squared plus 2AD. The fourth equation, displacement is equal to Vi multiplied by time plus 1 half acceleration times time squared. And finally, equation number 5, displacement is equal to Vf multiplied by time minus 1 half acceleration times time squared. So how do we use this? We will use this by determining what is given and what is unknown. Let's try to put this in a table. 4, 5. We have here final velocity, initial velocity, acceleration, time, displacement. So let's try to see what are the variables present in equation 1. So in equation 1, we have final velocity, initial velocity, time, and displacement. So we don't have acceleration. In equation number 2, we have final velocity, initial velocity, acceleration, and time. We don't have. Okay, so we don't have displacement. So let's have an x here, x here. So we don't have displacement. For equation 3, final, initial, acceleration, and displacement, we don't have time. For equation number 4, we have initial velocity, acceleration, time, and displacement na wala naman tayo ngayong final velocity. And finally, equation number 5, final, acceleration, time, displacement. Wala naman tayo ngayong initial velocity. So as you could see, it depends on what is given and what is being asked. So let's say ang given is final and initial. Tapos hinahanap is final, initial, tapos acceleration. Okay? Let's say dito natin plot si baba. So let's say ang problem, merong final velocity, initial velocity, tapos may acceleration. Tapos hinanap yung displacement. So ito ang displacement na hinahanap. So sa time, hindi natin kailangan. So let's try to determine ano ba meron yan. Check dito. Check dito sa BI. Check kay equation number 3 sa acceleration. Check kay displacement kasi yun ang hinahanap. So that means, if this is the problem, ang kailangan natin is equation number 3. Same goes. Let's say, meron tayong final velocity. Meron tayong initial velocity. Meron tayong given na displacement. Hinahanap natin yung time. So, hindi kailangan sa acceleration. So, if we could sit here, VF, VI, time is unknown, displacement is given. So, we will use equation number 1. So, that is how we will use these equations in a table. So, this is how we could easily see which equation would be best suited for every problem. Okay, so thank you and see you next video for other worded problems.